Fellow at the Department of Mechanical Engineering, IIT Kanpur. Earlier, he has been Director of the Indian Institute of Technology, Guwahati, and the Director of CSIR Research Institute at Durgapur. He was the GD and VM Mehta Endowed Chair Professor and Dean of Academic Affairs at IIT Kanpur. The research group of Professor Biswas has IIT Kanpur identified the phenomenon of Rayleigh-Taylor instability during superbubble formation in the film boiling. I would like Dr. Biswas to please address the gathering. Thank you.
Thank you very much indeed for your introduction. Good afternoon, all the respected viewers. Just again, let me check whether I am audible. Just give a response whether I am audible.
Yes, sir, you're perfectly audible.
Okay. Okay. So it is really such a delight to address, this gathering of many experts and many researchers and many budding researchers in the field. I'm very sorry that I could not be present physically in the ambience to enjoy the vibes and enjoy the interaction because of some health related limitations. Anyway, let me start the talk. Topic of my lecture is dynamics of vapor bubbles in various regimes of boiling with and without external electric field. Now, entire boiling paradigm can be divided into three groups. One group is nucleate boiling, another is film boiling. These are two major groups, and in between it is called transition boiling. Now, nucleate boiling, as you can see, we have animated from our computational results. Heat transfer occurs due to superheated liquid, microconvection currents, and microlayer evaporation. The heat flux is below the critical heat flux, and bubble dynamics is governed by number one, degree of superheat of the superheated liquid and the morphology of the heating surface, whether it is hydrophobic or hydrophilic, and the contact angle. On the other hand, film boiling, it is a paradigm where heat transfer occurs from superheated surface to the vapor film, and then the vapor film grows into bubbles, and we have written the growth rate which is given by omega as a function of physical parameters and Weber number Webb number. Webb number is m. Omega is the growth rate, Webb number is m. Rho, sigma, etc. are the properties, surface tension coefficient, density of liquid, density of vapor. And this, if you exclude the last term, actually growth rate is given by first two terms according to the original expression or original findings of Novak Zuber, famous scientist in boiling. But then because of influence of electric field, sometimes because of microgravity applications and several such fields, several such areas, externally electric field has to be applied. And the third term comes because of electric field. You can see the electric field E and the permittivities also appear. And this is basically modification of Zuber's dispersion law by Johnson. So now, if we look at basically the film boiling part, it is root cause of it is buoyancy driven instability, and it is conjectured that Taylor-Helmholtz instability takes place at the vapor-liquid interface. As you can see, this is a picture, actual picture, and this is basically a schematic. Now, as I said, it is a periodic phenomenon. Bubbles are released periodically from the nodes and antinodes, spatially. Temporally also, it is periodic, but I will come to that part little later. So, the in buoyancy-driven instability, as I was mentioning, vapor bubbles are placed on a square grid with a spacing that is basically distance between two adjacent nodes or two adjacent maybe antinodes equal to Taylor's most dangerous wavelength, which is given by lambda 0 equal to twice pi root over 3 sigma divided by rho L minus rho G into G, which can be written as root 3 lambda C. If we take out root 3, remaining terms will form lambda C, which is characteristics wavelength. And you can very well see that characteristics wavelength is dependent on surface tension coefficient, density of liquid, density of vapor, and the gravitational acceleration. And this is Taylor's most dangerous wavelength. It is called because when the regular bubble dissemination starts, the uh, distance between two nodes or antinodes are given by this. And this was found out through rigorous experiment of Berenson. And then, several scientists tried to fit in analytical model to Berenson's experiments, and this scenario was obtained. So here I will explain basically a computational paradigm, that how all these things which were done by uh, Zubair and Berenson, how those can be summarized, and then something else, some additional information can be extracted, which we did indeed in our computations. So, void fraction, we use CLS VOF algorithm. This is basically combined level set and volume of fluid method, very well known method, volume of fluid, and level set is added to that to refine it more, where void fraction is given by, as you can see, rho minus rho G divided by rho L minus rho G. So obviously for the space that is occupied by vapor, it will be 0. And the space it is occupied by liquid, here it is colored with blue color, it is 1. So this is a definition of void fraction. And because of heat and mass transfer, this, for example, the front shown here, this will progress or recede. Now, movement of this is basically advection, and this advection is governed by this is temporal derivative of f and divergence of velocity in the field vf equal to 0. Now, after having obtained the void fractions, if we can refine the void fraction as level set function, how we do it? Basically, we do not discriminate between the zero cells, discriminant, all the zero cells, for example, if we assign a small sign function, small negative value, all the one cells, if we assign a small positive value, and then interface will be sharp and it will have zero value, which will basically, be located between minus small quantity and plus small quantity. So this is basically the interface line or sharp interface. And all these are redefined based on value of f, remapped, so to say, on phi. And then the inter in if you take out any cell where interface is falling, then the major characteristics parameter of that interface cell is the basically liquid occupancy and vapor occupancy. And it is, if it is a piecewise linear element which is separating these two, then the surface normal on the interface, and the surface normal on the interface is given by grad phi divided by modulus of grad phi. So, now let us take a space where grids have been laid and a zone occupied by liquid, and maybe this is a zone occupied by vapor, but this is a curved surface. How to really find out this curved surface? The first successful interface construction was done by Young's. It is called piecewise linear interface construction, where you can see every interface cell has been the curved surface has been redefined by linear interface or linear sections. And so this way we can approximate a curved surface, but you can see this is, there is basically, interruptions. And in order to bridge that, it's not smooth. You can refine the grids, maybe 1 million grids or even more grid points can be taken. But even then, mathematically, you are not smoothing out this difference because of maybe a huge grid resolution. It may appear as a curved surface. So how it is done, I will just explain it. First, let us explain how to calculate surface normal. Now, surface, for example, if this is a cell, which is a two-phase cell, this is the liquid occupancy and this is the vapor occupancy zone, then the at the interface, the surface normal is calculated from the void fraction values of the neighboring cells. So if this is I cell of interest ij, we have to take into account all neighboring cells. That means I plus 1, j plus 1, I plus 1, j, I plus 1, j minus 1, I minus 1, j plus 1, I minus 1, j, I minus 1, j minus 1, all the neighbors. And this way we can calculate basically the direction cosines, and from the direction cosines we can calculate finally the surface normal. And then we have to calculate the offset distance of the interface from the center of the cell, which is given by L. So this N and L, these are the indicators of all interface cells. And as I mentioned it earlier, that mathematically every linear intersection, they have to be connected so that there is continuity. Otherwise, mathematical discontinuity is there. For that, we adapt a method which is called least square volume of interface reconstruction technique, called Elvira. So this is basically we define a function which is optimized with the guessed volume fraction and the actual volume fraction, and optimization space, you can see in 2D it is a 3 by 3 matrix, and in 3D it will be 3 by 3 by 3 matrix. So the F is the actual void fraction and F hat is the approximation, and this approximation has to be optimized in such a way, graphically you can see that this G function has to be 0 or minimum. If you are located here and say, for example, this dotted line is the interface passing through, and you are passing a normal on this cell, then the optimized um, uh, approximation of the dotted line can be done when you are located here, G becomes 0, you will get an optimum location of, on this dotted line. Similarly, next cell. So it is thought that mathematical continuity is established. And having done that, we go for the level set function little redefinition. Level set function, as I said, that minus small quantity in gaseous region, 0 at the interface, and a plus small quantity in the liquid region. And if we can really find out this sharp interface, then normal can be from the guessed field, we redefine, map the whole entire field on level set function, and then again we recalculate surface normal, and from surface normal we recalculate curvature, which is minus divergence of n, and n is given by grad phi divided by modulus of grad phi. And it is found while implementing, easier would be instead of minus small quantity, all minus deltas are considered as 0, all plus deltas are considered as 1, and this 0 and 1 is bridged with a Heaviside function for the smooth variation from 0 to 1. Otherwise, equations will not be able to will not be able to work with the equations, the numerical space, it will break. And then if this is the redefinition of the void fraction, then we can calculate void fraction based density as we have written here, and void fraction based viscosity. And this is rho g is the density of the gaseous phase, rho L density of the liquid phase, mu G is the density viscosity of the gaseous phase, mu L is the viscosity of the liquid phase. So at the interface, we get this surface tension force, which is given by the coefficient of surface tension, curvature, and grad of F, and this coefficient of surface tension is calculated from divergence of grad of F divided by modulus of grad F. So when we solve a two-phase flow system, there is a catch, because if it is isothermal flow, only maybe liquid and air, then we do not have this problem. But the boiling flow, which we are showing here, we have always phase transition. That means some cells with some space will be occupied by vapor, some space will be occupied by liquid, and always there will be interaction between the liquid and the vapor zones because of continuous energy transfer from the surface that is holding this. From surface energy will come, enter into the gaseous phase without having done much change. It will go to the liquid phase, and it will convert some amount of liquid into vapor. Then vapor zone will increase, liquid zone will decrease. So this interaction we have to handle, for which all the continuity equation cannot be different. So whether it is gaseous phase or liquid phase, when it is pure fluid, pure liquid or pure gas, we have continuity equation. In the two-phase cells, what we do, basically we try to do mass balance between the liquid phase and the gaseous phase. Energy that comes to the liquid phase, some amount of liquid is converted into vapor and then it goes to the vapor phase. This is a perfect balance equation, and the vapor phase volume changes. So basically, this is also a conservative form of conservation equation, which is synonymous to continuity equation, but for the two-phase cells. Q has to be carefully found out. Proper heat flux jump needs to be observed. So this is called jump condition. Then at the interface, what we can do, we can calculate the surface forces. So surface force says we'll have two components, normal and tangential. Now tangential component is present when there is surface tension gradient. Surface tension gradient driven by temperature, like del sigma del T. But in here, since it is boiling flow, so basically there is phase change and entire interface will be at the constant temperature. So there will be no gradient of surface tension. So this term will be zero. We will get only the normal term. And it has to be convoluted by delta Dirac function. Only where the interface appears, it will be there. Other places, it will not be there. So we, based on this philosophy, we go for modified momentum equation. You can see the usual momentum equation has been modified by using the white fraction based density, white fraction based viscosity, and this surface tension force has been added. This is, one predominant body force. Another force which also will act, I have just written it here, I have not explained it so far. It is basically volumetric electric force. As I said, the lecture is on in presence, with or without external field. As I mentioned, some microgravity applications, we have to apply external electric field, and then this volumetric electric force will be generated. Because of paucity of time, I do not know whether I will be able to cover much of this, but I will try to hit upon some results. So finally, the solution technique, as you can see, it is staggered grid arrangement, uniform grid spacing, finite difference discretization scheme, second order accurate in space, convective terms in the momentum equation are discretized by scheme. This is essentially non-oscillatory scheme of Professor Stanley Osher, very well known scheme, zero artificial viscosity. Convective terms in energy equation are discretized by quick scheme. Strong coupling between continuity and energy equation I have already shown, and the pressure equation, like pressure velocity solver, that is in this version of what I am showing today, it is connected with a open source pressure velocity algebraic multigrid solver called Hypri. Otherwise, we usually solve it with BiCG stab, our own handwritten program. But this part becomes much faster if we use algebraic multigrid solver Hypre for pressure velocity iteration. Okay. So now a test problem. First test problem as such in this presentation today I have shown only one test problem. This is a infinite plate. This is infinite zone occupied with vapor, infinite zone occupied with liquid. All these infinities are added because the we are comparing it with Stefan problem, which is one direction. Rather one dimensional phase change problem. So basically, heat flux goes to vapor. It heats the vapor a little bit. Remaining heat flux goes to liquid, and then after entering the liquid zone, some depending on the latent heat of the liquid, some amount of liquid is converted into vapor. It comes back, and this vapor front progresses. So this progress of vapor front is ht. As you can see, ht versus t, a function of time versus time, and our solution and analytical solution of Stefan. Similarly, if ht is progressing, obviously it has a velocity. So the velocity is gradually decreasing, and because vapor progress of vapor front will be little, slow after some, time. And so here the velocity versus time plot, and this is also our CLS VOF algorithm and analytical solutions. We have been able to get a perfect match. Then we have applied to some unknown problems where it is very we get some new information. So this is a space on which we are applying basically thermal energy from below, and on this space, basically this is occupied by liquid. A thin layer of vapor is there, and because of undulation of uh, between the liquid and vapor interface, this bubble formation sites are being formed, and these bubble formation sites, distance between two bubble formation sites, that means distance between two nodes or two antinodes, can be thought of a length which is wavelength. And so here we can see for Jacob number 2.54, that means delta T2K, 6 bubbles have formed on this space. And if you do the calculation, you will be exactly able to see that this is equal to root 2 lambda c. Lambda c parameters you can compute from here, and it is basically root 2 lambda c. Which is Rayleigh-Taylor instability. So for lower superheat, these bubble formation sites are separated by a distance which is given by root 2 lambda c. Then we go for 6K. 6K, that means Jacob number 7.62. Then also number of bubble formation sites are such that lambda does not change. But if we go for higher superheat, that means 10K, 14K, then we can see that bubble formation sites are such that they are separated by a distance which we can call lambda b, lambda Berenson, if you recall, I introduced at the outset, and this is equal to root 3 lambda c. So we can see transition from root 2 lambda c, root 2 lambda c to root 3 lambda c. And with higher superheat, that means 14 or 18K, it is even more clear. You can see the bubbles have formed and they are getting about to get detached for both these superheat levels, and they are separated by root 3 lambda c. And then finally, at delta t equal to 20K, bubble formation sites remain same, but some of the bubbles are converted into vapor column. So instead of bubbles, vapor columns are shoot out from the sides. It is another transition. However, this was a new, relatively, I should say, new discovery. And this here we have shown completely computational results. Just out of the context I am mentioning, you might be knowing very famous professor in ISC, Professor Gaurav Tomar. At one point of time, he was my PhD student, and what we have shown here, he proved it analytically. We had a physics of fluid paper that in this regime, it has to be Rayleigh-Taylor instability, and in the higher superheat regime, it has to be, Taylor-Helmholtz instability. So this transition from Rayleigh-Taylor to Taylor-Helmholtz instability, here what we have shown computationally, we have also shown it purely analytically. So, if possible, we'll come back to that discussion later. Now I will show some of the historically captured features. One such result is given by Riemann and Grigul. These experiments were done in Technical University Munich. You might be knowing that Nusselt was the chair of this division there, and after Nusselt, Grigul took over. So this, experiments were done by Grigul and Riemann. Here you can see bubble formation sites, which, as we have shown, basically separated by root 3 lambda c. And in the regime of Taylor-Helmholtz instability, higher heat flux. And then alternate sites, you can see that the bubble, instead of bubbles getting disseminated, the water jets, vapor jets are shooting out, vapor columns are formed. So alternate nodes or alternate points are vapor columns or vapor bubbles. And then uh, all the nodes or all the antinodes, all the points become a source of vapor jet, even higher heat flux. And then further instability, this is called vapor column instability. It takes place even at higher heat flux. So these experiments are almost like, template of all researchers to validate. Now we also could get a match alternate sites of, you know uh, sites. If bubble formation is taking place here, then at the next point it will be vapor jet, and again at the next point it will be bubble formation site. And this was obtained at superheat of 20C, 20K I should have written anyway. So, and then if we increase the superheat, 25 degree, then all the bubble formation sites are converted into sites for vapor jet, validating Riemann's and Grigul's experiments. Here you can see a regular evolution cycle. If you consider the 0 point as node, then at one point of time, bubble is getting detached from node. At another point of time, these are getting detached from antinodes. That means from minus lambda by 2 and plus lambda by 2. And these are the different temperature maps, for the film boiling scenario. Now, as I mentioned, that we will touch upon, maybe today time is not sufficient to cover it, that in many cases, especially when this, our space vehicles go to outer space or, higher altitude, because of change in gravity, you will see this entire scenario changes. And to bring it back to the operational level, electric field has to be applied. So electrohydrodynamics is a very important paradigm. And here what we do, we basically couple it with electrodynamics. That means, as you can see, in absence of any magnetic field, the curl of E equal to 0, where E is the electric field, is given by minus grad of psi. Psi is the electric potential function. And electric displacement vector, which is divergence of D equal to 0, it is like Kirchhoff's law. And D is given by permittivity into absolute permittivity into E. So finally, this is the governing equation for the, basically, which is, as I said, which is like Kirchhoff's law. And then the entire electric field which is applied, because of that some force acts at the interface, not elsewhere but again at the interface. And this interface force, if we call it FVE, is given by these three terms. This is basically Coulombic force because of free charges present at the interface. This is because of permittivity gradient, and this part is called electrostrictive force. If the electric field is non-uniform, then there will be a gradient. And usually we are using uniform electric field, so we are not going into this. But with the uniform electric field also, these two, quantities have to be considered. The results which I have included here, those are for pure dielectrics. So any fluid which is having little, electrical conductivity can be considered as dielectric. Some are pure dielectric, some are called leaky dielectric. Now, leaky dielectric has this conductive effect more, and presence of free charges are uh, felt, whereas pure dielectrics, presence of free charges are not felt. So, first hand approximation, we have taken pure dielectrics, where this FV is given by divergence of basically a stress tensor,
Sorry
and
to
this
interrupt
stress
you,
tensor,
Dr. Bishwas. Can you hear me?
yes.
Really sorry. It's a humble request. We are bounded with the time frame, so I would request you to kindly conclude in the next 5 to 7 minutes, sir. Thank you.
Okay. So this is Maxwell's stress tensor. Uh, then, if we apply, for example, how it changes, I will just show you. For example, this is here delta t equal to 5k, and uh, this is the regular bubble formation sites. And then if we apply electric field on it, we can see that these bubble formation sites, are such that there are creation of many more nodes. The why? Okay. So, uh, and then we can see that, with the increasing electric field, as such, I should have shown. Um, Yeah, here 2K, 5K, 18K, 22K for different superheats. We have shown the bubble formation sites and the spatial instability. Together with temporal instability, I have not mentioned it here. Temporal instability is the average Nusselt number. If we plot with time, we will get the time period and the frequencies. And we'll see that for lower superheat, smaller temporal frequency and larger time period, as we can see here, uh, larger time period for 2K or very small time period for basically 18K. So, for lower superheat, characteristics is smaller temporal frequency and larger time period, and higher superheat is basically higher temporal frequency. And then influence of electric field, as I was mentioning, you can see the a number of bubble formation sites increase with increase in electric field intensity, and bubble release becomes aperiodic at higher electric fields. Spatial periodicity is again maintained. You can see even though the bubble formation sites are changing and number of bubbles becoming more, spatial frequency is changing, but periodicity is maintained. Whereas temporal side, we can see that for higher electric field, uh, it becomes aperiodic, whereas for the lower electric field, the periodicity is there. This is some animation related to how it works. As you can see, 5K without electric field, here 5K with 1 into 10 to the power 5 volt per meter electric field, and here field intensity is 2 into 10 to the power 5 volt per meter electric field, and number of bubble formation sites are a lot more here as compared to this. So, since the time is short, I will just quickly try to show some results which are, again, I would say, very attractive. That is, this, as you can see, the way the bubble formation is taking place, it is basically a profile which is, a columnar profile, and finally it is forming into bubble. And this shape of interface profile at different point of time will give different value. What we found out, that if they are properly scaled, then all these values will collapse on a single curve. Here, instantaneous y was changed by y star divided by t star alpha. Y star is non-dimensional value, that means z direction, a bubble axis z direction, that is non-dimensionalized with lambda c by 2, and this is r direction, radial direction. It is non-dimensionalized by again lambda c by 2, and time is non-dimensionalized by the viscous time. Then y star divided by t star alpha and x star into t star beta will collapse all the curves on a single curve with alpha equal to 1.25 and beta equal to 0.5. And this is for 2K. Similarly, you can see the same repetition, similar, all the curves collapsing on a single curve in the Rayleigh-Taylor instability regime. And where the heat flux is high, Taylor-Helmholtz instability regime, there also you can see similar such behavior. And as you know, that in computationally we say that if any computational physics finally can show some such similarity variables or similarity profiles, it is physically absolutely correct. So here also, through this similarity variables, y star by t star alpha and x star into t star beta, where alpha is 6.4 and beta is 4.5, and the superheat is 10K, we can see all the curves are collapsing on a single curve, satisfying the requirement of similarity. So I will stop here today. I knew that I may not be able to go for microgravity situation. If I get some opportunity, I will in future. I hope I'll be able to do so. So transition for Rayleigh-Taylor instability at lower superheat to Taylor-Helmholtz instability at higher superheat is justified. Increase in bubble density over the domain with increasing electric field. We could see that bubble separation distance decreases with application of electric field. The maximum bubble height is found to be almost invariant with application of electric field. This I could not show. This result I had to skip. Johnson's hypothesis, this result also I had to skip. These two results I had to skip. Then the next one, the study of interface profile during bubble growth showed that the bubble profile at different instants of time tend to overlap with each other if a proper scaling law is defined for length and time. We have just visited that. And the value of the scaling exponents depend on the degree of superheat as the governing instability mode. That means whether it is Rayleigh-Taylor instability or Taylor-Helmholtz instability changes with that superheat value. So this also we have seen. Just previous two results. Here you can see alpha and beta are different since it is in Taylor-Helmholtz mode. And here alpha and beta are different. It is Rayleigh-Taylor mode. So with this, I would like to stop. If you have any question, any doubt anywhere, you are most welcome.
Thank you so much, sir. Do we have any questions in the crowd, please? Yes, sir. Sure. Hello.
Hello.
Hello, sir. This is Dipankar from CMERI Durgapur.
Yes. Please tell me.
I have one or two questions. The
Yes.
first question is if the VOF scheme can alone simulate the bubble formations, what is the specific need for the CLS VOF scheme?
Oh, see, this is a very valuable question, very pertinent question also. See, VOF scheme, incidentally, I work very closely with Professor Stefan Zaleski, who is today considered as the custodian of Basilisk and Jedis. So, leaving it apart, that VOF is good enough to capture all these things, but VOF has a limitation. VOF breaks when there is severe tortuosity of the interface. VOF cannot work well. But but it works. If somebody is using JDIS or a basilisk, he will immediately say it works. And how it works? Because in JDIS or basilisk, you have to go to level 10 or level 12 or level 14 refinement, where you will need basically millions of grid points. And this is despite they have very good grid adaptability facility. They can vary the adaptive grid in the whole domain very fine to very coarse. Despite that, they need a higher, sort of large number of grids. But if somebody can have VOF with extremely good grid adaptability facility, like Professor Zaleski and Popinet, they have in their open source software Basilisk, then you don't need really level set. Level set is basically a relatively poor man's choice, because level set can capture the tortuosity very well. So with affordable grid size, where you do not have very powerful tool for adaptive grid, level set gives equivalent result. Level set and VOF, combined level set and VOF, that can produce equivalent result.
Okay, sir, I understand. Now, my second query is that you have shown single bubble formation, but in the reality there will be multiple bubble formation, and they will
No, no,
interact with
no.
each other.
I have not shown single bubble formation. Single bubble formation I was showing as animation, but
Okay, okay, okay,
this is multiple bubble.
okay,
What
okay,
I
okay.
was
I
showing,
understand.
this is completely multiple bubble.
Okay, okay. Okay, sir. Thank you, and
Okay,
please take care of your health, sir.
okay. Thank you.
Thank you, sir.
Can you
Thank
please
you.
have a
Thank
huge
you.
round of applause for Dr. Biswas?
Good afternoon, sir. Here is a Basan. Good afternoon, sir. Can you hear me?
Yeah. Good afternoon, Professor Sikarwar. Really obliged for your invitation and what all you did. And as I can see, I missed quite a few of my earlier colleagues, come friends, come co-workers like Dipankar Chattopadhyay or Amores Dalal or maybe Bonni Ray, uh, and few others, Sajin Singh Gautam, etc. So I'm very sorry that I could not be present, but I'm very thankful to you for organizing such a wonderful conference where you had really, good discussions and good topics which can, take us to the future.
Yeah. Thank you very much, sir. Respected W. Silvamurthy with us. He is a physically, yeah, and yeah, yes.
Dr. Silvamurthy ji, my namaskar. I, I hope you are doing well.
Yeah, thank you so much. And I was just listening to the last part of your talk, Biswas ji, and I wanted to see you in person. And maybe sometime you can come over here to our campus, and so that you can
Absolutely,
learn and
absolutely. I'm looking forward. If my health improves a little, I have already promised Professor Sikarwar that I will, maybe in September or October, I will definitely try to visit this wonderful campus. I have heard a lot about it. I have heard a lot about the excitements that are being brought about by the Amitians. So I really want to visit and enjoy that and
and you
see
have
that.
contributed so much, Dr. Biswas, for our country and also to IIT Guwahati. You are one of that institution which you have played a very important role in other IITs as well. And it will be a privilege, honor to interact, collaborate with you, and wish you all the best in your endeavors. Looking forward to seeing you in person and Amity. Thank you.
And Dr. Silvamurthy, I have no language to express my respect and gratitude for you. You have if you talk about country from DRDO is the organization which has really served the country by all means. So you are holding a very important position there, and I had opportunity to interact with you on several occasions. I'm really grateful for that, and I also wish you a nice health and
Thank you
nice.
for your blessings. Thank you.
Thank you so much,
Thank
sir. Dr. Biswas, I would like you to stay a little while more because we would like all of us to hear you in the closing speech. Hereby, we are beginning with the valedictory ceremony of the fourth biennial international conference on future learning aspects of mechanical learning 2024. I would like all the respected dignitaries to please come on the stage, namely Professor Dr. M.K. Pandesar, Director ACIT, Professor Dr. W. Silvamurthy, and Professor Dr. Basant Singh Sikowar. Can you please have a huge round of applause? I would like Dr. Basant Singh Sikowar to please address the ceremony for the closing speech. Thank you.
ladies and gentlemen. A very good afternoon, all of you. As we know that we are going to close to this 3 days activities and say that this is a mega activities. I really feel proud. The last 3 days, not on only India, most of the world scientists, they deliver the cutting edge technologies in their fields. Really, we people are enjoy all these activities. And on this, our respected W. Silvamurthy sir, as you know that prior to MIT University, he was chief in DRDO and he had experience with Abdul Kalam sir. As you know that he is one of the big man which has developed many indigenous technologies and sir contribution is appreciable. So big hand for our Silvamurthy sir. I really grateful. He always supporting. Because of him, the MIT has a H index more than to 146. His contribution, scientific as well as administration, we are growing exponentially. And we believe that with blessing of W. Silvamurthy sir, we will going in a like an H index more than to a 200 within a year. So thank you, sir. Yeah. I am delighted to welcome our respected founder president, sir, Dr. Ashok Chauhan, whose visionary guidance is a source of our strength and inspiration for all of us in MIT University. We are grateful for his blessing and supports. Our founder president's dedication to nurturing a culture of innovation and his relentless pursuit of excellence inspire us all. We are honored to have his guidance and vision steering towards the great achievement. Definitely, our respected founder president sir will join us online very soon. Sir, respected founder president sir always believe on God. I remembered when I joined MIT University in 2015, he just called one day in one day night and he told Dr. Sikarwar, whatever you want, you can do here. And nobody can stop you. So I'm really always say that he's always supporting us. So I request all of you, please give a big hand to our founder president, sir, Dr. Ashok Chauhan. And one thing I am telling you, this is a proud of us. He's more than 285-year old. And now you believe that he's working like 18 hours a day. He anytime he called, he asked what is going on, what is the facilities of our guest is okay, they are doing good, the food, everything. He's caring he's caring like a family member. And he always say that you have to take the advantage, take the knowledge of your elders, because IITs they are more than 40-year experience. So you have to be all the IITs professors here. You interact with them, you interact with faculty members. So sir, you are always pushing us towards the forward. So then it is really very proudful for us. I am the part of MIT University. With us, our director, MIT School of Engineering Technology, Dr. Manoj K. Pandey. He himself is electronics engineer. and he has a very vast experience in engineering. He's a kind of multidisciplinary guy, and he's always supporting our institute, our department, as well as every faculty members to going in a next level. By heart, he's very polite, but by principle, he's very hard. He's always follow the rules, regulation very strictly. So, sir, welcome. You are here. It is our great pleasure. Our Vice Chancellor, Dr. Balvinder Shukla, she will join us very soon. She is a dedicated academician. She always supporting. She always promoting the research. She always promoting this type of activities. And because of her dedications, we are organizing this type of conferences. So thank you, Professor Dr. Balvinder Shukla. She will come very soon to join us physically. All the delegates, as you know that last 3 days, more than 58 key talk, plenary talks, or you people have to take already advantage. Professor K. Mullidhar, Professor Gautam Biswas, you recently joined, and he is also in online. Professor Edgar, Professor Andlip Tariq, Dr. Ranjana, Dr. K.M. Singh, Dr. Rajneesh, Dr. J. Ram Kumar, Dr. Subhash Datta, Dr. K. Srinivasan, Dr. Ranjan, Dr. Dinesh Singh Thakur, Professor Dr. Manikant, Dr. Dheeraj, Dr. Srinivas Subramaniam from Malaysia, Mr. Ramesh, Dr. P.M. Pathak, Dr. Sachin Singh Gautam, Dr. Divakar Rakshik, Dr. Kishore Kumar, Dr. Jason Lee, Dr. Amresh Dalal, Dr. Mamila Ramishankar, Dr. Captain Dr. EVSN Murthy, Professor Dr. Ashish Vateja, Sandeep Patil, Subrit Bagga, so many lines. You see that we have a guest from Thailand, we have a guest from IIT BHU, IIT Kanpur, IIT Mumbai. So almost 15 IITs professors, they gave the talk in 3 days. Ladies and gentlemen, as you know that during the concluding, we are going to be give the award of 4 honorary professorship. And this is my pleasure. This is my, I'm simply say that honor and privilege to present the closing remarks in front of them. And definitely they are going to be a part of our Amity family. To all speakers from IITs, DRDO, ISRO, NITs and foreign universities, as well as our participation include the research scholars and students from the various institute and Amity University. Thank you for your valuable contribution. Your presentation and discussion have sparked new ideas and set the stage of future advancement in our field. This event has been a testament of power of collaborations, the signing the 3 MAU, significant milestone of our journey toward the hosting the innovation and research. I would like also be express my appreciation to organizing committee, volunteers for their hard work and dedication. Your efforts have ensured their smooth execution of this conference. As we concluded, let us carry forward the knowledge and inspirations we have gained here. Let us continue to push the boundaries of our discipline and work together toward the future filled with discovery and innovations. Thanks all of you. Thank you very much.
Thank you, Basan sir. Always a privilege to hear your words. Now, I would like Professor Dr. M.K. Pandey to please address the gathering. Thank you. A huge round of applause, please.
Thank you, Krish. Thank you very much. Good afternoon, good evening to all. It's a wonderful day today, and in the occasion of this, UP government has declared a holiday as well. So this was the another challenge that, and challenge opportunity that we had faced this morning. And but I must appreciate Dr. Basant and his team that for wonderfully organizing the whole day without any disturbance. Thank you, Dr. Basant, and all of the guests, all the delegates. I, from the core of my heart, to welcome you to the valedictory session of the fourth biannual conference Flame 2024 at the valedictory session. And we are very thankful that you are the part of this 3-day conference. As Dr. Basant has rightly said, this is a big event of 3 days, and where a huge number of papers and posters has been presented towards the contribution of the research and innovation by various scientists across the globe. At the outset, I would like to welcome our Honorable Founder President uh, to this valedictory session. And we are thankful to him that because of his great efforts and his love and affection, we always stretch ourselves to do more, to do better, and how we can inculcate uh, the excellence into every task. That motivation, our honorable founder presidents are always motivate us on these things. Let us have a huge round of applause for him. And even now, in the inaugural session, he has physically presented here, and today also he has asked us that he will be presenting online very soon. So, welcome you, sir, once again. I would like to welcome our Honorable Chancellor, Dr. Atul Chauhan ji, and he has already extended his good wishes, blessings to the success of this conference. And we welcome you, sir. With huge round of applause, welcome our Honorable Chancellor, sir, our Vice Chancellor, Madam, and on behalf of the whole MET universe, MET family, we would like to welcome our guests today, Dr. Gautam Biswasji. So he is online connected with us today, and the wonderful talk that he was giving is, I missed some of the part of it, but yes, I was fortunate enough to get some of the glimpse of that. Thank you very much, Dr. Gautamji. And I came to know that, learned that you are not well as well. I hope that soon you will get well, and you will come to the MET campus in physical in next best opportunity that you will find out. Thank you very much for joining this afternoon for the valedictory session. Thank you very much. I would like to welcome Professor Sivaraj Subramaniam uh, from University of Technical Malaysia, and Professor Dr. Edgar Epton, University of Tarapai, Chile, Dr. Jaston Lee, National University, South Africa, South Korea, I'm sorry, and Dr. Martin Teklet, Budapest University of Technology, Hungary. I'd like to welcome you all with huge round of applause, please. And we are really fortunate that you had made this conference physically, and all the four name I had given is they are the recipient of the honorary professorship also this in this session. So once again, I would like to welcome and my congratulations, welcome to the MET family, because the honorary professor is the part of the MET family. So thank you very much for accepting this honor from our side. Thank you. I would like to welcome our keynote speakers, those who have joined for 2 days, 3 days conference across the world. Like to welcome our Honorable Vice Chancellor, Madam Salamurthy, sir. Dr. Basant has already been told about. I must reiterate again, he is always with us, cooperating with us, guiding us, mentoring us, and always asking us to do further, to do better. Thank you very much, sir. And our Vice Chancellor, Madam, who is joined online, and she will be coming soon here. And she has already been given us the target of doing the as much hard work as possible. Thank you very much, for Madam, for joining. My colleagues on the dais, and you know that the legacy of the MET universe that I had already given in the morning session of the inaugural session, where we have 12 universities in India and 17 campuses across the world. 200,000 students are studying at a time. This in this education group and having a lot of campuses almost. And our ambition is the Honorable Founder President Sir and Chancellor Sir has given us the mandate to start open the university in each state of the India, and that we are progressing in a very huge speed. So with that mission and that vision in mind, and always we chase for and trust for the academic excellence with in with innovation. Research and innovation is in our root. And today morning also we had various sessions on the property right, IPR, and many more that always stretches our student and our faculty member for how they can move forward and take forward their research and innovations that they are doing it. And you know that the Flame 2024 that has already gained a lot of recognition among across the world. The type of the delegates and the galaxy of scientists and researchers, those who had come to this conference, has already been proved the that. And the we had, this is the fourth version as I tell, and that is covering a lot of, that has covered a lot of recent topics, including the engineering design, automation, industrial engineering, production engineering, automotive engineering, material science and engineering, so on, so forth. So many topics that has been covered. And I believe that now with the inclusion of the artificial intelligence and machine learning, that is being instructing every technology in the ground. And I believe that the mechanical engineer also should not think that the AI is for the computer science engineering also. And now is a huge application of AI, and it's a disrupting the complete industry. And I was just reading about the computational fluid dynamics, where the role of artificial intelligence is artificial neural network is very much for the approximation of the chaos that may occur because of the flow. So, and that may be soon getting replaced by the artificial intelligence concepts. So, please be ready yourself. Now, you had to implement it, and that to say, if you want to get the maintenance of the machines, maintenance of the machine will be very, very easy when you are including the artificial intelligence concepts into it to find out the exact precision based defaults in the machines. Moreover, the various other technologies that is latest in the ground in the industry, that has to be implemented and to be researched into how the mechanical engineer can also involve into these all the technologies, including the IoTs, even data analytics also. Even data analytics is being hugely used in the mechanical engineers nowadays. And IoT, of course, now the devices, the machines cannot exist in solos. Every device and machine has to be interconnect. And for that, IoT is the tool through which the devices can talk to each other on various aspects and issues. Robotics is being disrupting the industry in a huge way in terms of the manufacturing engineering, and how the robotics and manufacturing engineering can join hand to hand, go hand to hand for the betterment of this industry. Again, is the topic, will be the topic of the discussion for the scientists and the researchers taking away today this afternoon. And so I again congratulate to our team of the mechanical engineering, Dr. Basant and his team of the department, and the student volunteers. Of course, let us have a huge round of applause for student volunteers, those who have tirelessly worked hard, because conducting a conference for continuously 3 days, having 5 sessions parallel, is not an easy task. And I can see how our coordinators, the volunteers, the student coordinators, the faculty volunteers are running here and there for the smooth conduction of every session in time. So they are really, I appreciate their efforts and congratulate the Department of Mechanical Engineering for the grand success of Flame 2024. So with this, once again, I welcome all of you to the valedictory session. and you must have taken away a lot of best things in this company. Thank you very much.
Thank you so much, Manoj sir. Always a privilege to hear your words. We are privileged to have amongst us Professor Dr. W. Silvamurthy, Director General, Amity Science Technology and Innovation Foundation, and former Distinguished Scientist and Chief Controller DRDO. I request you to kindly address the gathering, sir. Can we hear it for Dr. Silvamurthy? Thank you.
Thank you. Very good afternoon to every one of you. I'm extremely happy to be here in this valedictory session of the fourth edition of Flame 2024, and where you had 3 days very fruitful deliberations, because I have been getting everyday input what all happened in that day with regard to the outcome from the deliberations. So I was so immensely pleased that you are not only looking at the present, but you are looking at the future, because the whole thing is future learning in mechanical engineering. So the whole purpose of the objective of the Flame 2024 has been achieved. But then we now have to achieve in a sustainable way the outcome which we have got through this 3-day deliberations. Now, how do we take it forward so that there is a sustainable outcome for all the participants and all those who have joined online, and also for Amity group of institutions, that how do we harness the potentials of the connects which we made in this Flame 2024. Let me start with conveying the blessings from Founder President, the best wishes for each one of you, and he will also be addressing you soon. And you know, he himself is a chemical engineer, so he is an engineer by profession. So being a chemical engineer, that he is able to solve problems and also look ahead, make strategies. Because engineers are not just scientists who translate them into a deliverable. So there is a lot of the translational part and then a lot of strategies which are required for this converting a knowledge into an application. So that is what is the role of mechanical engineer. Because having been from DRDO, which makes strategic defense from land, air, water, underwater, to have the second strike capability, if there is any country venturing on India, that we should be able to give a second punch. So this is what is the strategic defense, where again mechanical engineering is the mainly the important thing in terms of our deliverable coming for strategic defense. Then we have also the missiles like Agni, Prithvi, Akash, Nag, Trishul, BrahMos, interceptor missile, ballistic missile defense. Everywhere it is mechanical engineering. Because mechanical engineering is all pervasive in technologies. So if you look at the saying that technology drives the doctrines of a nation, both in war and peace. Because in war, you will decide your strategies, military strategies, planning, everything will based on what technologies you have. Similarly, in peace, the technology will decide your position at the Committee of Nations. That is going to tell your economic strength as well. So that is why it is said, technology drives the doctrines of a nation both in war and peace. And this technology development, mechanical engineers play a very important role. So as a university, Amity universities are committed to churn out the future global citizens who will who will assume leadership positions in various institutions, various industries, and various capacities, so that we are preparing. So if it is so, the Flame 2024 has given us many ideas that how do we fine tune or bring a new paradigm in teaching the mechanical engineering courses to our students. So one aspect of learning from this the Flame 2024 is what changes we need to bring in teaching at undergraduate, postgraduate, doctoral level. That is one aspect I'll deal with. The second aspect will be what are the research focus priorities where Amity Group as well as the other participants should look at when you are looking at the futuristic. So I'm going to talk to you in these two dimensions. And when you look at the Viksit Bharat, which was talked in the morning and also yesterday in the inaugural, a day before yesterday at the inaugural session, India is looking towards, it's an aspirational India. We were just following up, narrowing the gap between the developed nations and the developing world. But now we would like to see that India emerging certain niche areas as a leader so that we will also be able to show to the world that yes, we were a knowledge superpower once. We had Vedas, Upanishad, Bhagavad Gita, Yoga, Ayurveda, and we were having Nalanda University, Takshashila University, but then we want to emerge, re-emerge as a knowledge superpower. So we have to generate new knowledge. We have to secure the knowledge through IPR, apply the knowledge for wealth generation as well as to create a happy world and improve the quality of life. So this is how we look at the future. India being the youngest nation, we have a large number of students like those who are standing here and then who are in their laboratories, who are in their departments, in institutions. So this is the youngest India with a median age of 28 years, which is the most creative, innovative phase of one's life. That population is here. So now we are looking at how do you transform them as the future global citizens in the mechanical engineering domain as well, for which the focus is going to be based on the deliberations in Flame 2024. One is advanced materials, because materials is the building blocks of any systems. So for mechanical engineer, that's the raw material. So to build any system, you need the right kind of materials in terms of whether it is strength, the malleability, the conductivity, and many other properties which you require to build a system. So the advanced materials, looking at Industry 4.0 as well as Industry 5.0. So we are now looking at this 5.0 as well. So the one important lesson which we learned is in the education of mechanical engineering, bring multidisciplinarity. This is very important. A mechanical engineer should know not only mechatronics, which is electronics, but he must know advanced materials, he should know artificial intelligence, IoT, quantum technologies. So everything must be brought in. So the first thing is learning is multidisciplinarity is very important, because when an industry looks for an employment, he doesn't need one mechanical engineer as he may have the core strength in mechanical engineering, but he should know project management. He should be able to see how do he apply the data analytics in mechanical engineering. So these are the ones they will be looking at. So we should bring multidisciplinarity and multi-skilling in a person. This is one which we should build. The second is design, development, prototype evaluations, and ultimately the quality, safety, reliability testing, and manufacturing and delivering it to the quality to the customer. So the whole supply chain, what is required from mine to market for a system or a system of systems, the mechanical engineer should be aware of. So he should know from ABC, from a concept to design and then design to the deliverable. In the advanced materials, I would like to say smart materials is going to play a very important role. Then we must also look at metamaterials is another area where we should look at. Quantum materials is another emerging area, quantum materials, and all these are very, very important domain. Normally, like developing a medicine or a new molecule to take it to human application, it takes about 10 to 15 years. You have to go through various trials, which is true for any new materials. Development also from the concept and identifying a material to go into qualification, certification, manufacturing, and then application will be 10 to 15 years. But now you can compress the period with a new concept which US has developed. This concept is very important, that quantum genome, the material genome concept, material genome initiative. Please read this. This is like a genome in the genetic engineering. Now they have brought that concept to material development. So once you look at this material genome initiative, read about this, and then that will talk about how do you compress this 10 to 15 years to develop a new material that you can reduce it to about 3 to 5 years. So that is how, this is what we should teach our students, that what is this material genome initiative. Similarly, we should look at digitalization, which is going to come in all platforms. So digitalization, we should give a focus in this mechanical engineering. Then miniaturization, because we would like to have everything compact. Because we used to have a big telephone now, so we have now a mini mobile phone. So like this miniaturization in the mechanical system, how do you reduce the size, weight? All this is going to go, and that's where the microelectronics, nanoelectronics is going to play a very, very important role. So the mechanical engineers should know about this. The very important area ultimately will be system engineering. Because this concept, we want to develop new system. It could be in a military parlor, could be a tank, main battle tank, or it could be an aircraft, or it could be a spacecraft, or it could be a satellite. So where, or it could be a airborne, early warning and control system. So everywhere you need system engineering. So that capability we should build. Design capability, system engineering capability. This is very important for not only defense, but in every area, whether it's automobile, to build a new car with a new design, system engineering is very important. The other one is project management. How do you manage such big programs or a project? So here, this concept, every mechanical engineer should know the concepts, and also robotics in manufacturing, additive manufacturing, and these are areas. Then quality, reliability, and safety is other area. So the mechanical engineering teaching should look at a new paradigm. I hope the deliberations will go to all the participants. So look at collectively that what is the change globally we can bring, not only in India, but in all the institutions who have participated across the globe. Can we look at a new paradigm in teaching mechanical engineering? Coming to research in mechanical engineering, the defense technology is a big focus in India. That's why combat vehicles, aerospace, naval system, directed energy weapons, high energy materials, sensors and communications, artificial intelligence and cyber security. These are all very important domains in which Amity is focusing. We have started a Amity Institute of Defense Technology in which we are teaching BTech, MTech, PhD in these areas where mechanical engineers, many of the students come from the mechanical engineering discipline. So the defense technology is going to see a new paradigm in our country, and we are giving a focus on self-reliance in defense technology. Automobiles is another niche area where India has assumed a good position there in terms of new designs coming in, manufacturing sector coming in the automobile. So automobiles again will see a big growth, and mechanical engineers will be required. And this transportation will be mostly green technologies like electric, then biofuels. How do you use it in your engines? So engine technology in which look at biofuel, hybrid technologies, electric vehicles, electric mobility is going to be the future. Then the AI application, IoT, quantum. And quantum is going to come in not only quantum materials, but quantum computing, quantum for the keys, for making the quantum key for cybersecurity. So all this will be applied as a part of a system developed through mechanical engineers. The final message will be congratulations to all the honorary professors who are going to be receiving the honorary professorship. We have more than 300 honorary professors from Stanford, Oxford, and Cornell, Kyoto, and Osaka. So like this, from many universities, we have honorary professors. So we are privileged to have another additional 4 of the honorary professors who are going to really enrich as a force multiplier in bringing new thoughts, new ideas. We are so grateful to you that you have kindly accepted to receive the honorary professorship soon. But this honorary professorship also brings a responsibility that we like to connect with you. And whenever you are here in the region, please come and interact with us, guide us, and also mentor our students. You can be a co-guide for our PhD scholars, and you can take a few classes online from there. So we would like to connect with you, already professors who are just sitting in front over here, that we like to get enriched by your wisdom, knowledge, experience, expertise. So thank you so much for being with us, and we look forward to work with you. Similarly, we have signed 3 MOUs, very valuable MOUs at the inaugural session. This Dr. Ashok Chauhan, the founder president, he has kept a concept that everything should have a sustainable outcome. So if we have signed a document like a memorandum of understanding, it's just not a document. It is a partnership. It is a relationship we are building with you, with your institutions. So we would like to harness maximum outcome for you as well as for us. So that is why we would like to look at from mechanical engineering asset at what will be the outcome. We have a directorate of outcome. There is a director there, Group Captain Kapil Shukla. So he would ask every 6 months, what is the outcome from this MOU? So we have streamlined process to derive the sustainable outcome. I'm sure Basant Singh Shikarwar, who has now spearheaded the whole mission of flame for the last 8 years. Now 4 editions have taken place. I'm sure the 5th one will be much more successful from the lessons which you have learned. I should say a few words about Dr. Basant Singh Shikarwar. He is from IIT Kanpur, and Dr. Ashok Chauhan, the founder president, has given a big vision for him. That how do you harness the wealth of knowledge, repository of experts available in IITs, institutions like our Gautam Biswas is there online, and he was director of IIT Guwahati, and then he moved to IIT Kanpur. He was also in CSIR laboratory at Durgapur. And so such a great people are there with very big knowledge. Dr. Sitaram, T.G. Sitaram, who was also the director of IIT Guwahati, who signed an MOU with Amity University. So he is now the chairman of AICTE. So such people are there. So how do we connect with them? So Dr. Chauhan created a consortium, IIT Consortium, IIT Research Consortium, in which now almost more than 20 IITs are connected, the old ones and young ones. But then we like to see more collaborations for the betterment of the humanity. So this mission synergy, he is the chief coordinator. So let's give a big clap to Dr. Basant Singh Shikarwar. And he himself is a great scientist, not only a great organizer, which you see here in plain, but then he has also delivered many things, and particularly 2-3 projects which he is doing, which I mentioned in the inaugural, but some of you were not there. One is how do you cool? The cooling, thermal management is a specialty. Mechanical engineering, thermal management, any system you develop will create heat. So how do you manage the heat? Some could create more heat, some could be less, but then heat is a problem everywhere. So he is looking at thermal management. And in this thermal management, he has developed for a high power laser, which is required for destroying an object in the air defense. You need high power laser. The laser, when you have the source, it generates huge heat. So how do you cool? He has developed a very novel method of dual pump cooling system. And so this is again now the project he's doing now. Then he is able to also concentrate from water. Water is becoming scarcity. So how do we harness the humidity available, water vapors available in the atmosphere, and how do you harness it in a way that you will be able to generate water, potable water from this? He has developed a system which can be used in many areas, particularly coastal belt, where you find a lot of humidity there. So this is the another area which he is looking at. Then second area is how do you provide hot water to soldiers or people living in high mountains, where in winter, during the nights, how do you give? So he has developed a paraffin-based cooling system, which is again a very important domain. Like that, I can go on telling about this Amity School of Engineering Technology, Mechanical Engineering Department. Then under his guidance and Dr. Neeraj Kumar, who is the additional director in Defense Technology, they have developed a regenerative clutch. Regenerative clutch. When the system is running, it is able to generate electricity. The heat which is generated is converted. Welcome, Founder President, sir. Dr. Ashok Chauhan ji has just joined, and thank you so much, sir. And he is the architect of research, innovation, the whole Amity group. Thank you for joining us. So I'll just conclude by saying that the Amity, we want to work with you. with you all. That is why Dr. Chauhan has created 3 missions. Mission Connect. We would like to connect with all of you. Then that should lead to synergy. So there is another mission, synergy, that it should be beneficial to you and it should be beneficial to us. So the synergy, mission synergy. Third one is the most important thing is mission outcome. Mission outcome is that whatever we do, whether it's a conference or it is a meeting or it is any endeavor of collaboration, it should lead to a sustainable outcome. It's just not that you came here one conference, we forget about it. You are connected permanently with us for synergy and a fruitful outcome. And ultimate aim is to see how do we improve the quality of life using mechanical engineering and other disciplines. Let's create a happy, healthy, peaceful, prosperous, harmonious world. And that is the main aim of Amity, Dr. Chauhan's vision, that how do we create a Viksit Bharat? How do you create a Shrestha Bharat? How do you create Atmanirbhar Bharat, self-reliance in technologies? And best wishes to you, Dr. Basant, Dr. Manoj Kumar Pandey, who is heading this asset, and all the, particularly students. Let's give a big clap to students who are here. You are the future. So they have been learning. They are not only organizing the event, but in the process, why do we make students come and attend this? That Chauhan said that there is active and passive learning. It takes place when you participate, leadership qualities get developed. So that is how you are involved, and you are going to be the future. And with this, once again, thank you, Basant, for this opportunity to share some thoughts. Biswas, we are all looking forward to hear you. And founder president has specially joined to talk to you. And Dr. Biswas could not come in person, sir, because of his just slight ill health. And I think with your blessings, he will also become all right. He was the director at IIT Guwahati, and then now he is in IIT Kanpur. And thank you very much, Biswas, for joining us on this occasion. Founder President, thanks for your blessings. Thank you.
Thank you so much, sir. Your words have always been an inspiration for us. Today, we are privileged to have the virtual presence of our VC ma'am, Professor Dr. Balwinder Shukla. I would like VC ma'am to please address the gathering. Can we hear it all for Balwinder ma'am, please?
No, Shukla, you are like a football. You don't know next minute where will be your. You here, there. I wonder how you do it. How you do it. But I am very glad that you have come to this function. I'll hear. Thank you.
Yeah. So, Honorable Founder President, I was in interviews of the faculty, so that's why I told Manoj that I will come online. But later on, I will come for the presenting the honorary professorship.
Great.
Yeah, so most respected Honorable Founder President, sir, a very esteemed guest of honor, Dr. G. Biswas, and all the recipients of the honorary professorship, and distinguished guest speakers. It has been really a great 3 days of conference, of international conference on future learning aspects of mechanical engineering. The vision of our Honorable Founder President has been that how to bring the great minds from across the globe for higher order of discussions, for ideas, for bringing the new technologies, practices, for making impossible possible, through the mission of connect, through the mission of synergy, through the mission of atomic. And today has been especially a very important day at AUP. In the morning, we had the controller of patent IPS of Government of India at Amity campus. The discussions which happened during that time And sitting there, and I was remembering that also we are having the parallelly the 3 days international conference, which is going to bring the big outcomes, because this conference has been really very special, because the great minds from the IITs, from the DRDOs, CSIR, international universities, when they are sitting and discussing and deliberating at the parallel sessions at different venues, and I'm sure that those audience were sitting there of the researchers, of students, how much they have learned, how much they have gained, and that knowledge which they have gained, how they are going to apply that knowledge to finding the solutions for societal needs, finding the solution for the industry problems. Because the mechanical engineering is the core engineering, whether it is the manufacturing sector and whether they are the many of the construction sector, where the mechanical engineering plays so important role. And the mission of our Honorable Prime Minister, the country's mission is the Viksit Bharat, where our Honorable Founder President long time back said that India be the superpower by 2030. So I would like to congratulate Dr. Basant Sikarwar. I would like to congratulate Dr. Manoj Pandey and entire team of the mechanical engineering department for working very hard and bringing such great minds under one roof. And now, how you people are going to work and develop the strategies, be connected for next 1 year, and coming back for the next flame, the 5th Biennial International Conference, the flame. And by that time, what the synergy you have built, what the outcome have been achieved, and then from there, where you will take the next trajectory, that we all together contribute to the Viksit Bharat by 2047. So once again, thank you all the speakers from across the globe, and congratulations to Team Asset for this wonderful conference. Thank you.
Thank you so much, ma'am, for addressing the gathering. We are privileged to have amongst us our guest of honor, Professor Dr. G. Biswas, IIT Kanpur, with us. Now, I would like Professor Dr. Basant Singh Sikarwar, Deputy Silvamurthy, and Manoj K. Pandey sir to please present Dr. Biswas with the professorship. Thank you. Dr. Biswas, am I audible? Hi, please address the gathering, sir. Thank you.
Thank you. It's such a delight to really address this August body, although I am, because of my personal health reasons, I could not be present there physically. I missed a great opportunity to interact with all of you, Honorable Founder, President, Dr. Ashok Chauhanji, Dr. Silvamurthy, Vice Chancellor, Professor Balwinder Singh ji, Director, Professor Shukla, one of the major organizers, Dr. Sikarwar, and probably I have missed some names of the dignitaries. I may be excused for that. But, as I said, all the dignitaries, I am so happy to be with you in this evening. And I would say that the conference, it was very rightly, pitched conference. If you look at it, is I would like to echo Dr. Silvamurthy that definition of engineering and definition of mechanical engineering as well. These are changing very fast. It's a paradigm which obviously that human race is progressing, and we are developing in several different ways, and all these are basically technology driven. If you take an example that using cheap, abundant, and clean sources of generating electricity is the basic idea of sustainable energy production. Now, electrical energy that is supplied through the power grids is generated from different types of power plants. These plants are generally three types, usually that hydroelectric power, thermal power, and nuclear power. Now, they are also, the hydroelectric power, big dams you cannot construct now. So new technology is emerging, which are called, if you know, entire North America, up this Erie, Ontario, entire that area, people are using bulk turbines, which are being installed in the fast flowing estuaries or fast flowing rivers. Thermal power plant, of course, fossil fuel, coal-fired power plants. There are also, many improvements. Some improvements are absolutely cutting-edge improvement, which is, today giving a plant efficiency close to what we could not imagine earlier, close to 40% or so. Nuclear power plants, basically, it's again, the focus is that how to make this world a safer and more sustainable place despite having nuclear power. Similarly, wind, geothermal, biomass, solar energy, everywhere, if you look at it, you will see that there are newer developments, newer science integrated with, technology. Our mechanical engineering today has significant contribution. Even in one area, probably Dr. Silvamurthy very nicely portrayed all the areas. Like transportation. Our transportation, the vehicles are undergoing a lot of changes. Today, we are going to electric vehicles, from electric vehicle to hydrogen powered vehicle, aircrafts. If you talk about energy, it is mind-boggling. Not only the grid power. Today, on a mobile phone, you have a lithium-ion battery, which can sort of power your mobile phone for many years. Of course, it has to be recharged. Now, another very important area is biology. Today, whether you try to do something which is very appropriately, sort of monitoring the blood flow or condition of heart or condition of any organ, you need basically intervention of devices. Those devices have mechanical component, electrical component, electronics component, but you should have the holistic knowledge to integrate all this. So probably interdisciplinarity is the major focus for which our entire curriculum, engineering curriculum, when we design, even past 3 semesters, there should not be any difference between the disciplines, whether it is mechanical or whether it is electronics or whether it is even physics or chemistry. Some amount of physics, some amount of chemistry, some amount of biology, mathematics, it is common for all to really, build up a mind that will accept the intellectual challenge in the respective fields in their later life, later course of completion of the program. So uh, and this is further tweaked today by artificial intelligence and machine learning. Of course, probably it is very, very, overemphasized everywhere. I am really not sure of, all kinds of nonlinearity. With due respect, our director sir was mentioning about CFD. I am a person in CFD. See, some of the areas like chaos or turbulence, it is probably, one can attempt, but where nonlinearity is huge, just applying the way artificial intelligence is today, it may not be sufficient, but I'm not against it. One has to learn it, one has to adapt it, and one has to really adapt it in a way so that our students are properly, uh, properly trained and properly, they can orient their mind how to apply and when to apply. So, as a whole, I would say that the progress of mechanical engineering is such that today uh, integration with electronics, integration with artificial intelligence, integration with biology, integration with chemical engineering. Some of the chemical plants or some of the chemical reactions, some of the products are such that without having proper knowledge of chemical engineering, the it is very difficult to move the knowledge front forward. So I'm little poorly organized in telling, what come first and what come next. Hydrogen energy, I was mentioning about hydrogen energy production and storage, transportation and application, of hydrogen is important. But, how to store hydrogen energy, uh, there lies a very big challenge. So, whether it is defense or it is, commercial world, following process, Silvamurthy's very nicely narrated phases of life, whether it is defense or it is in peace, we require technology, innovation to uplift the human being. And final effect is basically, we have to really do something so that entire society evolves. See, if there are poor, there are unfed, ill-fed, and the persons around, will you feel comfortable with your, whatever you are enjoying, or your uh, mm, possession? In a world where people are uh, uh, in a different phase, everybody has food, everybody has shelter, everybody has medicine, everybody has basic education. That is the situation we want to evolve. That is the situation we would like to welcome. And for that, technology is a medium through which we can implement many things in many places suitably. And, what I understand, the way Amity is approaching to this problem holistically appears to be extremely forthcoming and extremely helpful. I wish this continues and people get benefited and maybe in the near future we would like to see Amity University to emerge as one of the major academic parlance in the entire world. With this, I wish all of you the very best. I believe the conference went very well, and uh, the persons who have attended, experts who have exchanged their views, and students who have tried to learn, everybody has been benefited. I wish you a great success in your future endeavor as well. Thank you.
Thank you so much, Ms. Basir. Today, we are privileged to have amongst us Professor Dr. Shivarao Subramaniam. Professor Subramaniam is a seasoned researcher and innovation management expert with over 30 years of experience. He has served as the Deputy Director of the Research Management Center and the Founding Director of the Impact Innovation, Intellectual Property and Technology Commercialization. Now, I would like to call Professor Dr. M. K. Pandey, Professor Basant Singh Sikowar, and Professor W. Murthy to please present Professor Subramaniam with the professorship. I would like to call Professor Subramaniam for please delivering the acceptance speech. Thank you. Please have a round of applause for Professor Subramaniam.
A very good afternoon to our founder, Amity University founder, sir, Chancellor of Amity, Vice Chancellor, Deputy Vice Chancellor, Director, sir, Head of Department Mechanical Engineering, and also Dr. Sandramurthy, sir. It has been a great pleasure for me to be here, shared of my experience, and also I've learned a lot of things from the experts, those who have been invited for this event. And I really thank to the Amity. I believe it's not the starting point. It is not the end of what I received. It's the starting point for which we are going to work much closer in exchanging ideas, in making our journey to a better endeavor. Thank you so much once again to everyone here, and thank you so much for everyone in Amity.
Let's welcome VC ma'am with a round of applause, please. Professor Edgar Estupinian is a distinguished academician and researcher in the field of mechanical engineering. He currently serves as the director of the Department de Engineering Mechanica at the University of Chile. Professor Estupinian has made significant contributions to the advancement of mechanical engineering. I would like Professor Dr. Balwinder Shukla, Professor Silvamurthy, Professor Shikowar, and Professor Pandesar please present Professor with the honorary professorship. Please deliver the acceptance speech. Thank you.
Good afternoon, everyone. Good afternoon, distinguished authorities, founder president of MIT University, Professor Sita Ward, dear students, professors, all the staff from the mechanical engineering department. Just a few words. I don't have enough words to express my gratitude for this distinction, which I humble accept to work and to collaborate together. 2 days ago, we signed an MOU, which you say the words wisely, that is not to sign a document. We need to work to get outputs of these MOUs. So this distinction also, I don't see as a distinction. I see it more as like a new responsibility, which I accept, and I expect to accomplish the expectations that you have with us. So thank you very much, all of you. Thank you.
Professor Lee has obtained the PhD from the Pusan National University, Korea in the year 2015. His research includes ultrasonic NDE and structural monitoring. He has won global PhD fellowship and many more awards. Now, I would like all the dignitaries to please present Dr. Lee with the honorary professorship. Let's have a huge round of applause, please. Requesting Dr. Lee for an acceptance speech. Thank you.
Thank you. It's my great honor to step up here. And then thank you for inviting me to such a great event here and also to the MIT University. This is a good chance to share my recent research work, and also I have learned a lot through this conference. And also I always think about how we express our knowledge to the students. I'm just remember one of my colleagues. He say to me always, when you make a decision or when you are struggling, when you make decisions, you always think about all the students. Yeah, I also have learned a lot through this event and also conference. Yeah, all the faculty members here, MIT University, also all the students here. Yeah, thank you.
Thank you, sir. Professor Dr. Martin Takacs is an associate professor at the Budapest University of Technology and Economics, currently serving as the head of Department of Manufacturing Science and Engineering. I would like all the dignitaries to please provide Dr. Martin with the honorary professorship. Let's hear it up for Dr. Martin. Requesting an acceptance speech from Dr. Martin.
Dr. Chauhan, President, dear Chancellor, dear Vice Chancellor, dear professors, ladies and gentlemen, esteemed colleagues of the Institute and of the University, and distinguished guests, I'm deeply honored and humbled to accept the title of Honorary Professor awarded by MIT University. This recognition celebrates primarily not my professional achievements, but much more the strong collaboration between MIT University and Budapest University of Technology and Economics. I extend my heartfelt gratitude to the leadership of MIT University for this honor. Your commitment to fostering a global partnership is truly commendable, and I'm privileged to be part of this vision. I'm excited to continue supporting the collaboration between our institutions to the advancement of knowledge and education. Our collaborative efforts will enrich our academic communities and open new avenues for research and innovation. Thank you once again for this prestigious honor. Thank you very much.
Thank you so much, sir. I would like to call Professor Dr. Ravindra Kumar to please award the best paper.
Thank you, Professor Basant, for giving me this chance. With the help of all the session chairs from last 3 days, we were evaluating the posters. And especially I want to thank Dr. Vishakha for helping me out to select 10 posters. Poster ID 558, author is Sivang, he is from IIT Delhi. Poster ID 379, author Mr. Viswas Teja, he is from Bark, Mumbai. Mr. Viswas, we will give you the certificate. We are just announcing now. Poster and paper ID 8080, Dr. Sachin Singh Gautam, IIT Guwahati. Paper ID 135, Mr. Akash Patel from MNIT Bhopal. Paper ID 411, Smile Kataria from Amity Institute of Nanotechnology, Noida. Paper ID 69, Mr. Prashant Kaushik, NSUT, Dwarka. Paper ID 464, Mr. Abdul Alim from Asset, Noida. Paper ID 508, Mr. Himanshu from PDP MIIT DM, Madhya Pradesh, Jabalpur. Paper ID 425, Mr. C. Ram Gopal, IIT Kanpur. Paper ID 35, Apurva Singh, Asset, Noida. Thank you. Thanks all.
Thank you, sir. It is a matter of great honor and privilege to have amongst us our Honorable Founder President, Sir Dr. Ashok K. Chauhan. Your motivating words have always been a source of inspiration for many. I kindly request you to shower blessing and words of wisdom to the gathering. Let's put a round of applause for President, sir.
My dear students, a very good and very important occasion for me. For 3 days program of Flame was so much a learning and so much joy and so much satisfaction for me, because what Basant Sikarwar has done, it is beyond my grasp. How he called best of the best people from IITs, from DRDO, from CSIR, and from the industry. Not very many times I have seen that such people came with such great interest, and this was also a result of the MIT IIT Research Synergy Group. I have given the mandate to Basant Sikarwar that there are 23 IITs in the country, and we want in the first go 10 professors or researchers, innovators from each IIT. This makes 230. and I could see the result. I was really so pleased and surprised that Basant Sagarwal is making it to realize this dream, because I always say, if you have to be exceptionally successful, then synergy is the only word. Nobody alone can fulfill the aim which one puts. My aim is to become the MIT, to become the number one university in the whole world. A few of my students will be thinking Harvard, Cambridge, Oxford, Wharton, they are there, but I will tell you now why I dare to tell it. I'll tell to my students, my dear students, if you have come to my university, it means it has the blessings of your parents, grandparents, your father, and everybody, because coming to MIT University is a certificate and guarantee to achieve in life whatever you want. I've been always telling, because in our university, everything is there. And now, before you get impatient to listen why I told MIT University number one, my children have studied in Harvard, Wharton, UCL, LSE, and I know from all, these are the best universities in the world. But what we are giving in Indian air, in Indian water, the sanskars and values, and the behavioral science, nowhere I could find it. I have lectured everywhere, but nobody I could find that these behavioral science, sanskars, values, blessings are there. Therefore, I dare to say that my students can achieve everything what they like. And Basant Sigarwal, you have to tell me sometime, how did you manage it? It is still beyond my grasp. Under the guidance of Dr. Manoj Pandey, you achieved something miraculous. And I think Dr. Ramurthy has also praised the students and faculty members. And yesterday, late night, I wrote to Manoj Pandey and Basant that I'll call you either at TKC House in my headquarters or meet at the campus for 1.5 hours to understand this. Because this gives us the faith that we all, those who are attending, students and my dear worthy guest, Dr. Gautam Vishwas, a very good connect. For D.V. Singh Saab, who was long years with me, the brother of my Vice Chancellor K.J. Singh, he was telling about Gautam Vishwas very much full of praise. And Gautam Vishwasji, I am so proud, and my emotions and feelings came back when D.V. Singh Saab with me. He was more than 15 years with me, and his brother was also. So I think these things are the matters. If you can understand, grasp, chew and grasp and practice it, then nobody can beat through synergy. For example, we have got given the honorary professorship to Dr. Sivano Subramaniam, to Edgar Chile from Chile, Dr. Lee from South Korea, Dr. Martin from Hungary. So that is the synergy. These people, I have read their biodata. These people are exceptional in these areas where the flame has delivered the lectures and got the lectures. So I would tell to my student, wherever you go, have a synergy. My mission is best of the East and best of the West. Through these are the Brahmastra. Nobody will tell you. Nobody will tell you, because this one can tell only with faith and confidence who has practiced it. I have in whole life practiced it, and I tell you, which Dr. Murthy might have also told, during unification of East and West, 1991, 1992, I told to my people, the whole German people who are working with me, that I want to be the biggest investor in East Germany. And loyal people like Basant Sigarwal or Manoj Pandey saw towards me, but they could not laugh, because to laugh before a boss is criminal. So, but they were not believing. But my dear student, I must tell you why I'm telling you. I must give you the confidence that I became the biggest investor, having biggest investment there, and 8 big factories with the workforce of 6,000 Germans and 2,500, 8,500 German Europeans were reporting me. Otherwise, people think what Indians are. We are better. They are better, but if you learn from them and they learn from us, then we can achieve everything. So, Gautam Vishwasji, I'm very glad. I must tell you one thing. I have got very other similarities also. When you born, I was in the I did high school that year, 1956, and you born in the month of May. That is very important for me, my family, and the whole MIT group. My son, Dr. Atul Chauhanji, who is the Chancellor of IUP and also President of the whole foundation, he also born in the month of May. And the next is that I will tell you, your health was a little disturbed. On Monday, I will call you. You will report me, sir, it has become much better because when whoever comes in the MIT campus, there is a air, there is a water, there are blessings. People come here with a little disturbance, they go healthy. So I want to be sure that my this belief, does it come true or not. So I will not take much time because students she
Thank
also
you, sir.
quite some time. Dr. Murthy, your speech is always marvelous. Today also you spoke very well. Dr. Briminder Shukla is 25 years with me, and I always say, out of 1100 universities, she is my best vice chancellor. Nobody can. Dr. Manoj, do you agree, sir? She's my best vice chancellor and working day and night for the campus. 40,000 students, it's impossible. So what I want, I thank everybody, those who have come. Vasant Sikarwal will meet soon. Yesterday late night I wrote to your Manoj Pandey. I am impatient now to further advance my dream to become the best university in the country. I have tried to explain my students so that they start also believing. And if anybody doesn't believe, then I will explain them again. My dear student, again I request anything you want to achieve. When I come to campus, bring a small slip that, sir, we want to be billionaire. We want to be this. We want to be big industries in New York or Germany or anywhere. And if you don't get it, it is not the problem of Manoj Pandey, not of Vishwas, sorry, this Pandey and Vasant Sikarwal. It will be my problem, not problem of Dr. Shukla, because if somebody has done himself something, I'm not a TED speaker. I have not read good books, how to be a billionaire, how to succeed. I have done from -0. And therefore, I say, why my students cannot do? I would have not been admitted in MIT that time. And you are in MIT, my student. So, Vasant, my great congratulations. Manoj Pandeyji, my great congratulations. And Vishwaji, you are now at IIT Kanpur. I tell you, I have a good bonding with the IIT Kanpur. When my daughter, who is a alumni of Wharton, the most brilliant leader in the world, she was to marry, then I had hundreds rishte from the boys, and I chose one boy, Nitin Batra from IIT Kanpur. It means my love and affection for IIT and for Kanpur, and also we had made you must be knowing, MOU with your university in very earlier.
Guwahati.
Yeah, Guwahati, and Sitar Manji has come from there at AICT now, and Guwahati is also very close to us, her. And now Sitar Manji is ICT chairman. So I would say all these things we should fructify it, we should utilize it. No sentence, no word I hear out of which I don't make anything. I make of everything what I make, and this flame will be such a, what should Dr. Ramji say, supersonic, super,
Hypersonic.
Hypersonic, right? Hypersonic weapon. And we will show to everybody that whatever I said, every word will be fulfilled. And I'm grateful to all, I'm thankful to all, and my special blessings, my special appreciation to my brilliant students, faculty members, everybody. Thank you very much. I've never spent so much time in any program, but because it is the Vasant Sikarwal and Manoj Pandey, I left everything else. Just I came right back here. A big delegation came from my Bhubaneswar campus, and we decided we immediately make a university there, and Amrita Asha and all. So if you think something, know something, then no time waste, start it. So Manoj Pandey, Vasant Sikarwal, Dr. Shukla, Sri Pramurtiji, now this is a new era starting from me. Synergy, synergy, synergy. Thank you very much.
Thank you, Founder President, for your gracious participation and the message of blessings to all the participants, including all of us here. And then you are a man of the action and also a person who has done it, success by compulsion. So that is what you have proven by your leading there, and not only a great visionary, unparalleled leader, but then we are here because of all your blessings, and I am sure whatever you have dreamt will happen, and Amity will be the number one, and we are all working towards that objective and the goal which you have set for all of us. Thank you so much for joining us.
Thank you for the blessings and inspiration, sir. Now, with the closing remarks of Play 2024, I request all the dignitaries to please come up for the dais for the photo session. I request all the guests to please join the photo session. Ma'am, all the respected faculties, please join the photo session. All the student volunteers too, please join the photo session.